Hey everyone, welcome to part 4 of the video series in which we examine the life cycle of writing and deploying a Chialisp smart coin. This video is going to be a continuation of the piggy bank coin that we have been building in the last 2 videos. If you haven't already seen those, you're probably going to want to check those out before you start here. When we ended the last video, we had just finished building the first iteration of our piggy bank coin. This coin is technically a valid coin. We can even see that if we build it using the cdv clsp build command, we can see that it compiles successfully. This is a good way to check that your Chialisp is actually valid. Whether or not the coin does what it's supposed to do, that's a whole other issue. When I ended the last video, I had mentioned that this coin is not very secure and that you shouldn't publish it to the network. Let's go ahead and talk about why. When you want to spend a coin, you have to create something called a spend bundle and send it to the network. Once your spend bundle reaches a full node, that full node is going to send it to other full nodes, and the process repeats until a full node with your spend succeeds in farming a block. Because your spend is bouncing between all of these other nodes before it actually ends up on the blockchain, it has the potential to be changed by these other full nodes before it is actually farmed. For example, if the node who was actually farming the block decided that they were going to be malicious and try to extract more fees, they can manipulate the solution values so that the coin lights most of its value on fire. If we had, let's say, my amount of 300 mojos and we wanted to do a new amount of 400 mojos, if the farmer was smart enough to recognize this puzzle and see these solution values, what they're going to do is they're going to change this to 0 and they're going to change this to 1. The reason they're going to do this is because these values are not asserted at all. They can change it to whatever they want. We already have a piggy bank that is worth 300 mojos. And so if we pass it these values, what it's going to do is it's going to create a new piggy bank coin, but it's going to create a piggy bank coin with the value of 1. This spend still succeeds because new amount is greater than my amount, and it has not reached the target amount. So we're just going to create a new coin with the puzzle hash and a new amount. That's going to light the other 299 mojos on fire and turn that into fees for the farmer. We don't want that. So we need to make sure that both of these values are asserted. We also need to make sure that my puzzle hash is asserted, because if we don't, people could just put in whatever puzzle hash they want there, and instead of recreating a new piggy bank, we're just going to recreate a coin to someone's wallet. We don't want to do that. So we need to make sure that every single solution value is secured in some way. It is very worth your time to go through every solution value and figure out, if someone tried to change these, how would this spend be invalid? For my amount in my puzzle hash, it's actually pretty simple. We have conditions for it. It's assert my amount and assert my puzzle hash. The reason we are able to do this is because these are asserting values that are unique to the coin that is being spent, and the whole network can see that. So if the spend outputs these conditions, it can check that the values are actually the values that are on the coin. Let's go ahead and add those conditions to both of our spend cases now. We're going to go ahead and add lists. And the first is assert my amount. And also assert my puzzle hash. Simple as that. Because these are our coin properties, we can actually assert that they are true just with a couple of conditions that don't cost anything. So that's easy enough. But now we have the trickier one, which is new amount. New amount is not something that exists on the network already. New amount is something that you are giving to this puzzle to use as a value. If, let's say you put in, we have 300 mojos again, and we put in a new amount of 400, we want to contribute 100 mojos again. What the farmer could do is they could just change this to 301, and then you have spent a coin alongside this piggy bank coin that was dropping 100 mojos. This piggy bank coin is now only going up 1 mojo, so the other 99 mojos are again left over and get lit on fire as a fee to the farmer. So we need to make sure that this new amount is secured in some way as well. A lot of times, the way to secure your solution values is via a signature, but that creates a problem for us here with the piggy bank coin. Firstly, in the requirements, I decided that I wanted anybody to be able to spend to our piggy bank coin. Maybe we're doing this as a fundraiser for charity. We just want anybody to contribute to this that wants to. Secondly, a signature adds a lot of cost, and I don't think that we need to add that much cost to our piggy bank coin every time it is spent. So what we're actually going to do is we're going to create an announcement, and I'll explain how that works in a second, but let's go ahead and add it. Create coin announcement. And then we're going to be announcing new amount. Now, create coin announcement doesn't actually do anything on its own in terms of this spend. If you only publish the piggy bank spend, this would still be able to be manipulated by a farmer or a malicious full node. But what it does allow us to do is it allows us to assert this announcement from other spends. When we're spending our piggy bank coin, we're not only spending the piggy bank coin up to a new value, we're also spending a coin alongside it that goes down to another value of equal amount. If we assert the announcement from the piggy bank coin in the coin that we're spending alongside the piggy bank coin, then we can make sure that if anybody tries to change new amount, the coin that is contributing the money will fail, and then we'll have a piggy bank coin that has all this leftover amount being added, but no funds to add it with. And so the only way that they can make this spend go through again is by adding the funds themselves. And if other people want to contribute to our piggy bank coin, that's fine by me. So now we have secured all three solution values. It's worth mentioning that creating the announcement actually prevents another kind of attack called a replay attack. We want this spend to be spent alongside the coin that we are contributing with. If we didn't tie this to the coin we were contributing with in some way, someone could actually separate these spends and they would just push our transaction that goes down a certain amount. For example, we're contributing 100 mojos. We have a coin that's worth 200 mojos. We're spending it to a coin that has 100 mojos. If they excluded the piggy bank coin, that coin might still go through and we would just light 100 mojos on fire to the farmer. So it's important to recognize that when you have two spends that need to go together, it's important to tie them together in some way, and usually that is done with an announcement or a signature. That should completely secure our coin. Now, whenever we push this spend involving this coin to the network, any amounts that we solve it with will all be asserted in some way so that if anyone tries to change it, the spend is not going to go through and they're not going to be able to spend our coin. In the next video, I'm going to talk about a concept called currying, which could make this a little bit more general for other people to use. If you have any questions on everything that we talked about here so far, please head over to our Chialisp channel on Keybase and ask us some questions there. We'll be happy to help you out. Until then, I will see you guys in the next video.